example of the house that I'm working on is called the Energy Plus House because it belongs to the housing developer. Okay, a housing developer want to show something about technology that they have. Okay. So if they want to do the zero energy house, it means that you have to use a very small amount of energy and produce something. Okay, you have to produce some energy, but you have to save on energy use first. Okay, so it's not very difficult for Thailand because we live in the climate that is very, I would say that is very comfortable compared to other countries. Okay, we can make use of natural ventilation, even though sometimes we complain that it's too hot, but it's still okay when you compare to other countries. Okay, so this really use concept of natural ventilation. Yeah, and okay, the building, the house gonna be naturally ventilated, and put a big shading device on top, like a double roof. Okay, and the double roof, you put some solar cell to generate electricity, so that it can be zero energy. Okay. Yeah, this is like a system that we use. Okay, we have a concept of building in hot and humid climate. Okay, the building in Thailand, you can see that we have traditional house made of timber or wood, and we also have a Buddhist temple made with very thick wall, concrete, brick wall. You know why? Same climate. The same climate in Thailand, we have two very, I would say that very different buildings. Traditional Thai house and Buddhist temple. Okay, because the people know that during the daytime they can live downstairs, and they need to have thermal mass to do some thermal absorption. Okay, and during the night they can live on top using the material, lightweight material. Okay, during the daytime we use heavyweight material. Okay, but during the night time we use lightweight material. That's why this building use concrete for the living room. Okay, concrete for the living room. But for the bedroom we use wood, timber. Okay. Yeah, this construction is a prefabricated construction. Okay, it's a block put on for the foundation. Okay. It's like completely knocked down. Yeah. For the planning, we have concept of this one. Okay. This called a Dogtrot house. Okay, from for the southwest of the USA, people use natural ventilation in hot, humid climate. Okay, you see that they intentionally put the hole in here, so that the wind can flow to the hole with high velocity. And then they put it like a living room. Okay, living room outside. Yeah, it's called Dogtrot house. I would say it's a good vernacular design of hot and humid climate in the USA. Okay. Yeah, it's the effect of Dogtrot house. Venturi effect. Okay, you have inflow to the space between the room, and you can use it like a living room, outdoor living room, because the air speed is gonna be increased and help you feel comfortable during the daytime. Okay. So I put it in the planning of this house. Okay, we have a Dogtrot here. On the second floor we have Dogtrot here also. Okay. The planning is like a traditional Thai house. Okay, it's not very compact, but it's like it's separate. Okay, so that you can have more airflow. Yeah, and we test on simulation of airflow CFD to make sure that we have enough wind speed. Okay. Here is this. Okay, Dogtrot. Yeah. Outside shading. This can make very big difference. Okay, if you can put shading at the outside, you can save a lot of energy. Okay, because during the daytime, no people stay in the house. You warm it at all times if you don't protect it from the sun. And when you go back to your house, it's very hot. Okay. Yeah. Okay, the plan to use is like a laboratory. Okay, for the student to put on some measurement of temperature. Yeah. Okay, we use the program Energy Plus, okay, in the design builder software to generate the energy consumption report for this one. Okay, this one. Okay. And we come up with the temperature inside. Okay, you don't have to look at this. Okay, it's very difficult to look at this. Okay, but always say that the energy consumption of this house is like about 40% of typical house. So the area is like 130 square meter. Average indoor temperature is about 29. It's not too bad. Okay, but don't have to compare with the temperature in the inside. This one is like 25. Okay. Okay, but if you put air conditioning, okay, it's gonna be 25. But for the outdoor, you can make it 29. I think it's okay, not too bad. You have wind airflow also. Energy cost is here, not many. Okay, energy index, I told you before, 48 kilowatt-hour per square meter per year. Typical Thai house is about 90 kilowatt-hour per square meter per year. Average house. So we can reduce it like by half. Okay, energy use is like here, 6,500 kilowatt-hour per year. But we can produce more than we use. Okay, we can produce with solar cell more than 2 times. So it's called Energy Plus House. But if you want to save on your money, you can reduce the amount of solar cell. Okay, you don't need to have that much